So last time we looked at all our different solving methods, from just factoring to quadratic formula to completing the square to square root method. Today we're going to focus on some more specialized types of solving these. And again, when I assess you guys, I'm just going to give you all the different equations. You have to figure out what the best method is for solving them. So it's just a practice piece in recognizing what's going to work. One I want to talk about is graphing in the calculator. So we talked about always checking your answers, but if you have an equation, I mean, you can always just take what's on one side and throw it in y1, and what's on the other side and throw it in y2. If they hit each other, it has a solution. If they don't hit each other, it doesn't. Now the problem with these is always going to be the window. So 3x squared minus 2x, we all know is a quadratic. We could find the vertex. The y-intercept is clearly 0, 0. And that's going to look, it's going to open up, okay? 4 is just a line going straight across. So if you hit graph, you just got to hope you have the right window, or else you got to kind of play around with these things. So there's our two solutions where they hit. How you actually find those is second trace, go down to intersect, and first time through you could just hit enter, 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 and it'll give you one of them. So negative 0.868. So clearly not something we're going to be able to factor. So we had a quadratic, we had a line, there's your two solutions. To find the next one, second trace again, go down to intersect. Now you're going to have to move your cursor over to get it closer to the second one. You can see down here it says first curve. So is the quadratic the first curve you want to intersect? You hit enter for yes. Up top it says second curve, and it shows you the equation. Y squared, or y2 equals 4. Is that the second curve? You hit enter, enter again, and 1.535 is our other solution. Okay, so you can always graph these things to check. Obviously, sometimes I'm going to ask to see all the work for it, but it's at least another strategy. If you didn't have your calculator, you could easily take this one here, swing this 4 over, and just crank through quadratic formula. You'd go through, you would solve these things, and you would get these two solutions up here. You could just leave them as far as the fractions go, or get the decimal out of it. But definitely factoring wouldn't work for that one. Square root method's not going to work either, because it's not set up for that. Completing the square, you could certainly do that. But when you pull a 3 out, you're here. If you want to take half of 2/3, it can kind of get a little dicey, especially since you have to distribute that through there. So graphing or quadratic would really be the best method for that. We've worked on factoring by grouping. Like we said, the only new thing with solving is we make it equal to 0. So if you see 4 things, you know it has to be a grouping. So there's no collecting of like terms here, they're all different. So typically they'll give it to you kind of in the order. So pull out your GCFs. If this is negative, you're always pulling that out. These match up. These match up. So this factors x squared minus 4 and an x minus 1, and this equals 0. You got one solution here once you get it down to a linear form. Remember, we need 3 solutions. If you wanted to get this thing completely factored, recognize this is your difference of squares. There's your other 2 solutions. You could check that in your calculator, and it's going to work. You could graph this one as well. It just becomes a little bit different if you wanted to check your answer that way instead of the table. So x cubed minus x squared minus 4x plus 4. So if you graph this, it's going to be a cubic. We're going to study these. You studied them a little bit before. You see it crosses the x-axis 3 times. Those are our solutions. Now the trick is you can't intersect this unless you have something to intersect it with. So you're trying to intersect it with the x-axis, so it's important you throw a 0 in there. And you can go back and make this line darker so you can actually see that. Now when you second trace, you'll get those 3 solutions there. So there's another kind of little special case. Grouping is going to be a dead giveaway whenever you see 4 terms. Lastly is a substitution example. Now there's 2 ways you can do this, a quicker way and a longer way. So if you just saw this right now, you get a quantity x plus 3 squared plus 9x plus 3 plus an 8 equals 0. You might be tempted just to say, okay, well, I'm just going to expand this stuff out and I'm going to collect all my like terms. So let's try that method first and I'll show you the shortcut. Okay, I'm going to double distribute this quickly and collect all the terms. Of course, these equal 0. Uh, 9 and 27 gets you to 36, plus 8 gets you to 44. So you just turn this big mess into a simple little quadratic. You could complete the square, we could quadratic formula, or we could just try and factor. If you do these enough, you'll recognize you can multiply to 44 and add to 15 pretty easy. There's your 2 solutions. X equals negative 11, x equals negative 4. You check them in your calculator, or you graph it, it's going to work. Here's a different way to approach this problem. Forget that these are blobs as far as the x plus 3 goes, and just kind of look at the numbers out front. You get something squared plus 9 times 1 of that something plus 8. What if we just rewrote it this way? And all we're saying off to the side is that a y equals an x plus 3. It's called a substitution. Typically they use u's for these, but the u's look really weird, so I don't want the variable I chose to kind of confuse you guys. But this problem right here is no different than this problem right here. Everybody knows we can multiply to 8 and add to 9 pretty easy like that. So then your solutions become y equals negative 8 and y equals negative 1. Those aren't the real answers because you changed them from x plus 3's to a y. You did a little substitution. Now you have to go back and solve for that substitution. So you know a y equals an x plus 3. So let's substitute that in here. So x equals negative 11. You've seen that before. Let's go substitute this piece in right here. So then x equals negative 4, and your answers match up. So really there's 2 different ways to do it, kind of a shorter way and a longer way. Try and work on those substitution things and make those connections. That stuff comes in handy if you want to keep going and doing some interesting things with math. The last example we're going to look at, I'm not going to show you guys a solution. I want to discuss it first thing in class. So it looks like this. You get a blob times a blob plus something else, and then you got equals 5 with a different blob in there. So what do I do when I don't know what to do? Try all the strategies we've talked about. See if you can get it down to a simple equation where it equals 0. Try a method, check your answers, and we'll discuss this first thing in class.